Hi, 6th graders. We're on lesson 10.4 and 10.6, which is triangles and quadrilaterals. Our learning targets are being able to classify triangles and quadrilaterals and being able to find the missing angle measure of a triangle and a quadrilateral. So triangles can be classified by their sides and by their angles. So this video, you're going to have a little bit more note-taking than usual, so I apologize for that, but it's really important to get written down in your notebook. So the first thing that I want you to write down, I know it looks like a lot, but it's not really, is all of this, or this whole table. So this is showing how we can classify triangles by its angles. So here in the blue are the 3 different ways we can classify by angles. And then how we can classify triangles by its sides. So we already know the different types of angles, which are acute, right, and obtuse. An acute triangle has 3 acute angles. A right triangle has 1 right angle and then 2 acute angles. And an obtuse triangle has 1 obtuse angle and 2 acute angles. Then if we look at how we classify by its sides, we can classify by scalene, which means no congruent or no equal sides. Isosceles, which means it has 2 congruent sides. And equilateral means that all 3 sides are equal. So if we look at the triangles that are drawn in the boxes here, this one right here is an acute scalene triangle. It's acute because it has 3 acute angles, which are all less than 90 degrees, and it has no equal sides. These little hash marks here mean that they are equal. So this shows isosceles because it has 2 equal sides and all acute angles, and then equilateral because all 3 sides are equal and all 3 angles are acute. We can see that both of these triangles are right triangles because they have a right angle. This one shows that it's scalene because none of the sides are equal. And then isosceles is here because 2 of them are equal. We cannot make a right equilateral triangle because there's no way to have a right angle with 3 sides that are the same. And then we can see that this obtuse scalene has no sides equal. Isosceles obtuse has the 2 sides equal, but all angles, one angle is obtuse, the rest are acute, and then we also can't do obtuse equilateral. So if we look at it classified by their angles, we can see these 3 triangles all have acute angles. If we look at right triangles, they all have that 1 right angle. And then obtuse, we can see that there's 1 angle that is obtuse. If we look at it this way, we can see all scalenes have no sides that are equal. Isosceles, we can see that have 2 sides that are equal. And then we can see the only equilateral triangle that we can draw is also an acute one. So a few more examples. This is an example of acute equilateral because it has 3 sides the same and all 3 angles are acute and they're actually all the same as well. Here's an example of acute scalene. So we can see that these hashtags here, since they're different, it means that they are not equal. And all 3 angles we can see are less than 90 degrees. So it would be acute scalene. Here we can see this 1 angle right here is obtuse, so that tells me right away that it's obtuse. And then I can see that there's 2 sides that are equal, so it would be obtuse isosceles. And then we have a right angle, so right away that tells me that it's a right triangle. 2 sides are equal, so it's a right isosceles. Okay, the next page is going to be your next page of notes. So if you have room on the page that you're on right now to fill this in, or if you need to go to the next page, that would be fine as well. So now we're talking about quadrilaterals, which I know that you talked about before, and you know that quadrilaterals have 4 sides. So here's 2 examples of quadrilaterals. As long as it has 4 sides, it's a quadrilateral. Well, now we can break up quadrilaterals into more specific groups. So a quadrilateral can either be a trapezoid, which has 1 pair of parallel sides. We can see the top and the bottom are parallel. Doesn't say anything about equal sides, just 1 pair of parallel sides. Or it can be a parallelogram, which has 2 pairs of parallel sides. So we can see that these vertical sides are parallel, and then these horizontal sides are parallel. A trapezoid then can no longer be classified into anything else, so then it stops there. Parallelogram can be classified into a rhombus or a rectangle. A rhombus has 2 pairs of parallel sides, so we can see that this side and this side are parallel, and this side and this side are parallel, and all 4 sides are equal. But it doesn't say anything about the angles. A rectangle has 2 pairs of parallel sides also, and it has 4 right angles, which is not specified here, but each of these 4 corners are right angles. So really, since a rhombus and a rectangle are both parallelograms, we don't even need to say 2 pairs of parallel sides for a rhombus or a rectangle. We could just say a rhombus is a parallelogram with all 4 sides that are equal. And a rectangle is a parallelogram that has 4 angles that are 90 degrees. And then we can classify one more into a square. And a square, which is also a parallelogram, has 2 pairs of parallel sides. All 4 sides are equal, and all 4 angles are 90 degrees. So notice the rhombus has the 4 sides that are equal, but not the 90 degrees. The rectangle has the 90 degrees, but not the 4 sides that are equal. A square has both. So a square is actually a rectangle and a rhombus. So here's an example of a square, and then this also has the 90 degrees. So a square is a rectangle, a rhombus, a parallelogram, and a quadrilateral. A rectangle is a parallelogram and a quadrilateral. A rhombus is a parallelogram and a quadrilateral. So this right here can be classified as a quadrilateral, a parallelogram, or a rhombus. The best way to describe it would be a rhombus. The best way to describe this would be a trapezoid, even though it's also a quadrilateral because it has 4 sides. So when we're talking about polygons, which all of these are polygons, we want to describe it in the most specific name as possible. And then one last thing about triangles and quadrilaterals is that, and this you will want to write down in your notes, is that the sum of the angles, so if you add up all the angles in a quadrilateral, they equal 360 degrees. If you add up all the angles in a triangle, they equal 180 degrees. So very important to remember. So if you are given this triangle and you need to find x, I know that they have to equal 180 degrees. So I can do 180 minus 60 minus 60 again. And I know that 60 plus 60 is 120. So 180 minus 120 equals, 60 degrees. So x equals 60. degrees. Or we can get rid of that line. And then if we look at this quadrilateral, I know that they have to equal 360. So I can do 100 plus 80 plus 80, which I know that 80 plus 80 is 160, plus 100 equals 260. And then I can do 360 minus 260, and I get 100 degrees. So I know then that x equals 100 degrees because all four have to equal 360. So really quick, I want you to pause me and solve for x. I want you to find the missing angle measure for this quadrilateral. So you can take 70 plus 85 plus 45 and you get 200, and then you could take 360 minus 200 and you get 160 degrees. So x equals 160 degrees. So just a reminder that if you add up all the angles in a quadrilateral, you get 360. If you add up all the angles in a triangle, you get 180. Super important to remember. Please make sure to log into NICU and take your 10.4-10.6 NICU quiz. It's just one quiz, but they're together in one. Make sure you bring your notes to class tomorrow and have a super evening.